Welcome back. Let's talk about our fifth sorting algorithm, quicksort. Even just from the name, you're thinking, this is going to be quick. Quicksort, just like merge sort, is a divide and conquer algorithm, which means, and should ring a bell in your head saying that, there's probably going to be O of n log n. And if you're thinking that, you're right. You see, quicksort uses something called a pivoting technique to break the main list into smaller lists. And these smaller lists use the pivoting technique until they are sorted. But let me show you an animation of quicksort. Quicksort works like this. And if you're looking at this diagram like I am, and you're completely confused as to what is happening, this describes quicksort fairly well. It's pretty complex to understand. So let me show you a better demonstration. I have a little diagram here. Let's say we have a list that looks like this. We have 37895219554. What we do here is we pick a random pivot. Let's say that 4 is going to be our pivot. Once we pick this pivot item, we're going to say, all right, I want all numbers that are less than 4 to come to its left, and all numbers that are greater than 4 to come to its right. So what do? Well, we start comparing the numbers. We look at 3 and 4. All right, 3 is to the left of 4, that's fine. What about 7 and 4? 7 is higher than 4, so it should be to its right. We're going to move 4 to the left position to make space for 7. 7 jumps over to the right, and we swap the 5 that 4 came into the 7 position. And now we check 5 and 4. Oh, we got to do the same thing. We put 5 to the right of 4 and swap 9 in there. Once again, 9 is higher than 4, so 9 comes to the right of 4. Then we look at 8, same thing with 8. And then finally, 5 and 4. Well, 4 and 5 switch places. And now we have a list that has 4 as the pivot, and we know that 4 is going to be in that position in the array. And everything else to the left of it and to the right of it still needs to get sorted, but at least we know where 4 stands. From there, using divide and conquer, we now split the list, and we do the same thing. We get a pivot on the left list, which will be 2, and we say everything to the right of 2 should be higher, everything to the left of 2 should be lower, and we have this left list sorted. On the right, we do the same thing until we split the list with 7 in the middle, and we keep breaking things down like a tree, and this is where divide and conquer comes from, until we have all the individual lists sorted and we combine them. Now, you might have 2 questions for me looking at this. One is, how do we even pick this pivot point? And that is kind of random. It really depends on the situation, but as you see here, we just happen to pick the pivot point as always the last item in the array. The second is, how am I ever going to code this? And this is pretty challenging, and I don't expect you to get it. I'll leave code for you and you can try it out if you want. But the best way to understand quicksort is my favorite Hungarian dance ever. I'm not going to play this for you. You can play it on your own, but I swear I could watch this all day. I think the dancing is awesome, the music is awesome, and well, if you speed it up to 2 times, it's even better. Here in this video, let me mute this. You'll see that this person in the black hat is going to be the pivot, and everybody is comparing, the person in the red hat is the pointer, I guess, or the item that's being compared to the pivot. And you'll see here that as soon as we get to 2, this person is number 3, they're going to say, oop, you should be to the left of me. So they're going to dance. By the way, great dancing moves. I need to learn these steps. And 2 and 3 are now in different locations. And now we compare 0 and 3. Now, this implementation and the visual that I just showed you is a little bit different. But the idea is the same. Quicksort can be implemented in different ways, but the idea of a pivot is the same. I encourage you to watch this video to fully understand how it works underneath the hood. But let's go over the main concepts. Quicksort is really useful. And between quicksort and merge sort, I would say those are the most used sorting algorithms. You'll notice here 2 things. One is that quicksort's space complexity is really good. I mean, not as good as bubble sort or insertion sort or selection sort, but it's still better than merge sort. Its worst case is O of n squared. That is because it can be O of n squared when the pivot is the smallest or the largest item in the list, because then you're not really splitting the list in half. And because of this, you really want to make sure that you pick a good pivot for quicksort. You'll get the better space complexity, but the worst case could be bad. So in those cases, merge sort might be better. If your list was pre-sorted for whatever reason, and in that list, if we pick the pivot to be the first item or the last item, then our sorting routine here would take a very, very long time. Because again, the list will not really be split in half. And ideally in a quicksort, you're picking the pivot intelligently based on your list. Now, quicksort, there's a lot of variance to it and there's different implementations. But I want you to take this away from this video. Quicksort is usually the fastest on average. But the one downside is that it has some pretty nasty worst case behaviors. So if you have to guarantee no bad data, or you can't guarantee that the pivot's going to be good, then you should be avoiding quicksort. But on average, it's usually the best sorting algorithm. All right, so we've learned 5 different sorting algorithms. But the most important part is, when should I use what? In the next video, we're going to go over exactly that, followed by a fun little exercise. I'll see you in that one. Bye-bye.